For this project, a group of students from the History of Design MA programme at the Victoria and Albert Museum and the Royal College of Art recreated historic wood varnishes from recipes contained in a 16th century French technical manuscript. It is a satellite project of the Making and Knowing project based at Columbia University in New York. The project at Columbia is producing an open access digital edition and English translation of a manuscript which was composed by an anonymous craftsperson in France in the last decades of the 16th century. This project was a collaboration between curators, conservators, tutors and students of the V&A and RCA History of Design course.
I'm Marta Ivar. I'm the head of postgraduate program at the Victoria and Albert Museum in the joint V&A RCA History of Design program.
And I'm Simona Valeriani. I am a tutor on the History of Design MA here at the V&A.
I'm Nick Humphrey. I'm a curator in the Furniture, Textiles and Fashion department.
I'm Dana Melker. I'm a senior furniture conservator at the Victoria and Albert Museum.
I'm Nigel Banforth and I'm a senior conservator in the Furniture and Wood department.
Our role was to try to recreate furniture varnishes from 2 of the recipes included in the manuscript. As well as this, we also used the V&A's wide collection of furniture to explore the ways that this type of varnish might have historically been used. The students, tutors and conservators met on the 1st of February 2016 to conduct the experiments at Blythe House, one of the V&A buildings. We focus on the recipe for an amber varnish. The original recipe stated, the Germans boil the minium intensely in linseed oil, and to give it the consistency of varnish, they mix in heavily pulverized yellow amber. Due to the difficulty in obtaining amber, we substituted it with copal. Both groups set up our equipment by attaching a gas canister to a burner and securing a thermometer onto the side of our pots. The pot was set onto the burner, which was then adjusted to the lowest heat setting. We split into 2 groups, with one group heating the copal and the other heating the linseed oil.
So Nigel and I did lots of research before we met your group. And for us, because we hadn't actually done any varnishes, and also because the manuscript doesn't give a lot of information. So the 2 of us did both historical research, looking to see what documents we could find. I think a good source for us was a 19th century manuscript of a how to set up a commercial workshop to do varnish making.
For me, the kind of first, in a way, one of the most striking results of this experience was how elliptical the recipe is.
It made me think a lot about the materiality of a workshop and the fact that we always think about the processes and what goes into the recipe, but the problem arising when you do this recreation. The fact that on the one hand we can control much more the conditions, we have thermometers, we can control how hot we are heating something, which they would not have had. But on the other hand, we have no way of being sure that we are recreating the same conditions in which they were working and what kind of influence that might have on the finished product.
The linseed group added 1 litre of linseed oil to their pot and started to heat it slowly over the course of 2 hours.
It's difficult to understand how to judge the timing of using the ingredients. So we were told to heat the linseed oil over a certain amount of time, but that wasn't from the recipe, and it was kind of a bit like guesswork, I think.
It's like a comment, like we do it this way, and they, the Germans, do it like this and this and this. They're making a memory of what the Germans do differently.
Meanwhile, the Copal group had put 500 grams of Madagascar copal into their pot and began to slowly heat it.
Copal and amber would have been interchangeable in their description with varnish makers. And so we felt that that was a happy substitution.
They had to watch carefully to ensure that the resin did not burn, boil or start raising in the centre.
But the smell was very acrid, and I don't know about you, but
horrible.
it made me feel very lightheaded.
But the Copal was actually funny because the Copal actually had pleasant smell at the beginning, sort of incensey like.
The cues that we ended up really using were the sensorial.
The stirring was very instructive in terms of body knowledge. Obviously, the consistency of the mixture changed over time. This sense of how thick it was something that I think, again, with experience, you would contribute together with what it looks like to tell you at what point of the cooking process you are, because you would recognize by stirring how the mixture behaves.
Once the oil had reached 180 degrees centigrade, they added 2.5 grams of minium, 1 gram at a time while stirring the oil. Once the minium and linseed oil had been combined, the group heated the mixture for an additional hour, stirring occasionally. Heating the copal proved incredibly difficult and needed to be heated for several hours to actually melt it.
With the copal, because we didn't pulverize it, there wasn't an even size. So at the bottom, the dust was there, and that
burnt.
Pretty
Did
much.
it melt?
It just went sticky. You
So
couldn't
good.
evenly heat it, because so
No.
you have the outside was like melted, and then you'd crack that
crispy.
open, and it was still cold on the inside. Like you could see that the inside wasn't melting.
It's funny that we chose not to pulverise the copal, really.
Yeah.
Yeah.
Because it was in big...
Because I think
Yeah,
that was an oversight that we didn't realize until
Yeah.
after. What does pulverization mean? I mean, is pulverized like a fine dust, or is it sort of pebbly like we were doing it?
Yeah.
Again, sort of not really describing the visual that you're supposed to have. So the idea that that's a knowledge that the reader already has.
During the process, the weather conditions started to affect our experiment. The wind was blowing out the flames on our burners, so we moved our equipment to a more sheltered spot.
What remains in the memory is the blustery weather and the gloomy spaces that we were working in. The waiting and the uncertainty, needing to check constantly details. Do we light the stove now? Do we keep stirring? Is it getting hot enough? This doesn't feel right. Should we carry on? I think more than anything, it highlighted the lack of experience and knowledge that we were bringing to the recipe.
When it started to melt, maybe burn, it went a dark toffee color really, really quickly, and then went almost to a black brown within
I mean, at
an hour.
At the end, the spoon that we actually had to use was actually burned, charred. I broke a piece out of it.
When we melted it, it was only when it got to a slightly, not liquid situation, but definitely more liquid. You aren't dealing with something, you're not combining two liquids. So it's kind of like making a white sauce, is you're not expecting anything to melt, you're just trying to get them at a consistency where they'll combine.
It was the smell and also the colour. It kind of went from being quite a light yellow to being quite ambery. Yeah. And we knew that once we'd got it to that temperature, if we could maintain it at that temperature, it wasn't going to go any darker.
Once both groups had finished their processes, it was time to add the melted copal resin to the linseed oil. The resin was slowly poured into the oil while stirring, and the mixture was then put back onto the burner to heat until it was well combined. This method produced a very dark varnish that was extremely viscous.
What struck me, I think, about the process and thinking about the embodied knowledge of 16th and 17th century makers, from the point of view of furniture history, was the broader contextual knowledge that makers and users for these kind of products would have had at the time, in that if we're thinking about varnishes being applied to furniture, they're quite likely to have been applying the varnish, and therefore they knew the effect that they wanted, and they knew the kind of application that they needed from it. We had a very limited perspective. So for me, the process sent me out asking questions in different areas about what they wanted out of varnish, what it was meant to do, why go to the bother, the cost, the time of putting varnish on in the first place.
Our project at the V&A, besides the recreation of the varnishes themselves, was also to explore selected examples of early modern furniture while thinking about the varnishes that might have been employed in their production. After making the varnish outside, we went inside to the V&A furniture stores with curator Nick Humphrey to look at objects from the collection under UV light. Taking advantage of the rich collection of early modern furniture at the V&A, we looked closely at the different objects' complex finishings and, aided also by laboratory analysis, tried to understand their composition and stratification. We discussed how looking at objects under UV light is useful for understanding how varnishes were used. UV light is used to assess the surface of an object. Different materials fluoresce different colours under UV light.
And what happens is that the energy from our light excites some of the molecules that are on the surface, and that's what is going to be emitting the color. Different types of materials will have unique fluorescence colors.
For example, shellac fluoresces a bright orange colour, whereas natural resins fluoresce green. Adhesives and modern materials fluoresce a white-blue, and uncoated surfaces do not fluoresce at all. This information helps conservators determine how best to preserve the different objects in their care. We examined a variety of objects, including a 16th century Venetian frame that we had sampled for scientific analysis.
There's this frame, Venice, circa 1600. Next to it, a piece of late 16th century French furniture, a fragmentary panel. Over here we've got a range of surfaces, gilded, two gilded frames, but perhaps it makes sense to start where we've got a range of things and it's slightly easier for people to gather around at the same time.
You know, what we can immediately see is that we see a black background, we see some gold paint. Here we see that we're missing a wooden element. We've got the stones. We see these exit holes from previous documents. Yeah, furniture beetle. We see cracks in the surface, probably from, you know, wood movement here. Just looking with the visible light, it almost looks like there's fills. Okay, so now starting to look at this surface.
It's the stone.
This is the stone. And what can you say about this surface here? Yes, and you can see there's darker areas and lighter areas. So by looking at this, what we can tell is that this section here, which I think is not stone, this is the wood. Yeah. Okay, so maybe there's stone missing, but certainly it's meant to. It's black and, you know, with gold. So if we think this is a later addition, and we then compare the color fluorescence to the border around it.
Oh, yeah. It's the same.
It's the same. Can you all see that? So that's giving us a feeling then that whatever surface coating that we have on this is contemporary with this. Partially, you know, so you could make an argument, well, no, it's just the same material. But as things age and are exposed to sunlight, fluorescences tend to also change, just as the appearance would change in visible light, and probably, you know, become closer in their appearance over time. Okay, this is a piece of stone. So where maybe we might just think that our stone is polished and that's what's giving it its shine. Okay, if you turn that one off. So now I'm coming over here. What can we tell about that?
Varnish.
Varnish. It's definitely a varnish.
It's greenish.
It's greenish. So probably what we'd expect on this object then.
Which is a natural
resin made from
tree.
Yeah, exactly.
Yeah.
Exactly.
We would return to Blythe House the week after to try to make a lavender ore varnish and experiment further with the amber varnish recipe.